Lesson 5-4, Solving Inequalities. Mario is at a carnival and has already spent $15. If he brought $20 with him, how much more money can he spend? Write an inequality and solve. So Mario has already spent $15 at the carnival, and we want to know how much more he can spend, right? That's going to be our unknown, our variable. How much more money can he spend, right? We'll call that x. Now, we know this total amount that he spends can't be more than $20, right? Because he only brought $20 with him. So the total amount he spends, 15 plus x, must be $20 or less, right? And the symbol that we'll use to represent that is less than or equal to. 15 plus x must be less than or equal to 20. Now, in order to solve for x, in order to isolate the variable, we will use an inverse operation just like we would if this were a normal one-step equation. And really the only difference here is that instead of the equal sign we have an inequality symbol. Right, so we will undo addition of 15 by subtracting 15 from each side. And on the left side, it's a 15. On the left side, we are left with simply x, bringing down our inequality symbol, is less than or equal to 20 minus 15 is 5. And because this problem is dealing with money, we need our dollar sign, right? X is less than or equal to $5, which means that Mario cannot spend more than $5, right? The additional amount that he can spend is $5 or less without going over his budget of $20. Let's try another one. Joanne is saving up money to buy a new pair of shoes. If she needs to save at least $80 and is saving $5 per day, write and solve an inequality to determine how many days she will need to save. Okay, so the key words in this problem are at least. These words, at least, will give us a hint as to what inequality symbol we need to use. Alright, so the first thing we're going to do is write an expression that represents the total amount she saves. If she saves $5 per day, then $5 per day times the number of days, we'll call that D, number of days. 5 times D represents the total amount she saves. And we know this total amount must be at least $80. So what does that mean, at least 80? Well, that means it must be $80 or more, right? So 5 times D, the total amount she saves, must be greater than or equal to 80. Okay, in order to solve for D, we will divide both sides by 5. On the left-hand side, 5 divided by 5 leaves us with D. Bringing down our inequality sign, D is greater than or equal to 80 divided by 5 is 16. 16 days. So our solution, D is greater than or equal to 16 days, means that Joanne must save $5 each day for at least 16 days in order to save up her the amount that she needs. Alright, let's try a few more of these. Negative 7 plus x is less than or equal to 6. So negative 7 plus some number must be less than or equal to 6. Okay. Which inverse operation will we use here? Well, on the left-hand side we have a negative 7. And if we want to isolate x, we have to get rid of that negative 7, right? So we will add 7 to each side. And the reason we're adding 7 to each side is because negative 7 plus 7 leaves us with 0, right? So we are left with x on the left-hand side, bringing down our inequality symbol. X is less than or equal to 6 plus 7 is 13. So x is less than or equal to 13. And if we wanted to graph this, right, in some cases you may be required by your teacher to graph your solution. Okay? If this is 0, let's say 13 is about there. Alright, so we are interested in all the values 13 or smaller, right? Because x can be less than or equal to 13. So because this is a less than or equal to solution, we are going to use a shaded in circle, right? Or a closed shaded in circle at 13. And then we'll draw an arrow to the left, right? Because we want all the values that are either 13 or smaller, and the smaller values are toward the left. Let's try another one. X divided by 7 is greater than negative 4. Okay, in this case, in order to undo division by 7, we will multiply by 7 on each side, right? Because 7 divided by 7 leaves us with simply x. X is greater than negative 4 times 7 is negative 28. So our solution in this case is x is greater than negative 28, which means that any number larger than negative 28 will satisfy this inequality. And if we were to graph this on a number line, it would look like this. Right? If 0 were here, negative 28 would be about here. And because this is a greater than solution, right, not greater than or equal to, x is greater than negative 28, meaning negative 28 is not part of our solution, right? X cannot be 28. So we will use an open circle above 28. And because we want the numbers larger than negative 28, we will draw an arrow to the right. Okay. Now there's only one other thing that you will encounter when solving one-step inequalities. And before we solve another problem, I want you to consider the following example. Let's say we were comparing the two numbers negative 5 and 10. What symbol would I use to compare these two numbers? What inequality symbol? Well, less than, right? Negative 5 is clearly less than 10. Let's see what happens if I multiply both sides by positive 2. If I multiply my left-hand side by 2 and then my right-hand side by 2. Well, negative 5 times 2 is negative 10. 10 times 2 is 20. Negative 10 is still less than 20, right? But what if I were to multiply both sides now by a negative number? Let's say, I don't know, negative 3. Let's say I multiply the left-hand side by negative 3, and then I multiply the right-hand side by negative 3. Negative 10 times negative 3 gives me a positive 30. 20 times negative 3 gives me a negative 60. 30 is greater than negative 60. Alright, so what I want you to notice here, to recognize, is that when I multiplied both sides of my equation by a negative number, right, I multiplied both sides by negative 3, my inequality sign flipped, right? It changed from less than to a greater than. And that will hold true whenever you're solving an inequality and you multiply both sides by a negative number. Whenever you multiply both sides by a negative number, your inequality sign will flip. And I'm going to show you now that the same holds true for dividing. Okay, so let's start with my original example. Negative 5 is less than 10. Let's say now I were to divide both sides by a negative number. Let's say by negative 5. Negative 5 divided by negative 5 is 1. 10 divided by negative 5 is negative 2. 1 is clearly greater than negative 2. So just like when I multiplied both sides by a negative number, when I divided both sides by a negative number, my sign flipped as well. And this is something that you always need to keep in mind when you're solving inequalities. Alright, so let's try a couple of examples in which you will need to apply this rule. Negative 6x is less than or equal to 36. Okay, so I'm going to solve this the same way I would any other inequality, right? My goal is to isolate x, so I will divide by -6 on each side. But because I am dividing by a negative number, I must flip my inequality sign from less than or equal to greater than or equal to. Right, x is greater than or equal to 36 divided by -6 is -6. So x is greater than or equal to -6. Let's try one more. X divided by -8 is greater than -9. Okay, in this case, I will multiply both sides by -8, right, to undo division by -8. On my left-hand side, -8 divided by -8 leaves me with x. Now, because I multiplied both sides by a negative, right, just like when I divided both sides by a negative, because I multiplied both sides by a negative, my inequality sign will flip. In this case, it will change to a less than sign. Right, x is less than -9 times -8 is positive 72. So my solution is x is less than 72. And that's really all there is to solving one-step inequalities. See you in the next video.